Hello and welcome to lesson 2.8. Today we're going to look at inequalities and their graphs. So today we're going to look at graphing inequalities, and we're going to look at how to write an inequality. So if you recall, an inequality is a mathematical sentence that either has the less than, greater than, less than or equal to, greater than or equal to, or the not equal to symbols in them. So when we go to solve an inequality, when we're looking at solutions, a solution of an inequality is a number that's going to make that inequality true. So if I give you something like 3 is greater than -1, this is true. When we go to graph inequalities, if you are looking at the less than or the greater than symbol, we are going to use an open circle on the number. So use an open circle, and what I mean by that is you're going to do an open circle just like this. If we use the inequality less than or equal to or greater than or equal to, these we're going to use a closed circle, and I'm going to show you what these look like here in a second, but a closed circle is nothing more than something that looks like this. So let's go ahead and take a look at a couple examples. So for example 1, part A, it says graph the solution on a number line, and it says y is less than 3. So what I'm going to do, I have the inequality, which is a less than symbol. So I'm going to come over to my graph on the number 3, and I'm going to put an open circle, and then I have to find all the values that are less than 3. So you can do this in one of two ways. You can either think about it logically, and we can say that we know like the number 2 is less than 3, and 1 is less than 3, and 0 is less than 3. So if we know that, we're going to take and we're going to just kind of draw an arrow. So I'm going to fill this in just so you can see it, and then we're going to show our arrow going in this direction. Okay, and what this tells me is that any number that this arrow is, or the direction in which this arrow is pointing, any number is going to be a solution of this inequality. So if you look, I could pick the number like -10. Well, -10, if I plug that in for y, -10 is less than 3. So that would be a solution, just like anything else. But if I come over here on the side where the arrow's not pointing, let's say over here to the +10, 10 is not less than 3, so that is not a solution. Now, kind of a little cheat trick to this is if you have your variable first, like we do in this case with the y, if you notice, my inequality kind of looks like an arrowhead. So if your variable is listed first, the arrowhead or the inequality kind of tells you which direction to point your arrow. So notice that my arrow pointed this direction, and this looks like the less than inequality. Okay, so now if we go down to part B, let's see if we can apply this down here. Part B says that x is greater than -1. So because I have the greater than symbol, this is going to be an open circle on the number -1. So here's that. And then if I go with the arrowhead idea, my arrowhead looks like it's pointing to the right because x is listed first, or my variable is listed first. So that means I'm going to draw my arrow in this direction here, and that tells me then that every number to the right of that open circle is a solution. For example 2, it says graph the solution on a number line. Here I have a is less than or equal to a -2. So now because I have the less than or equals to symbol, I'm going to come over to -2 and I'm going to fill in or put a closed circle. And again, because my variable is listed first, I can look at my inequality here, and it looks like the arrowhead is going to be pointing to the left. So right here, and then I'm just going to go ahead and connect these two. Now for part D here, I can't go ahead and use that application directly because my variable is not listed first. So what I'm going to do is I'm going to rewrite it so that my variable is listed first. Notice that my inequality, that the open part of the inequality is facing the letter and the point is facing the number. So I'm just going to make my inequality open facing my variable. And then the point is facing my number, which is -6. So now that I have my variable listed first, I can see I'm going to put a closed number, on the number. We're going to put it on a -6. So that's going to be down here. So closed circle on -6. And we are going to be drawing our arrow to the right. So it's going to look something like this. So please go ahead and pause the video real quick, and I want you to try these two on your own. When we're looking at example 2, part A, it says x is greater than 0. My variable is listed first. I have a greater than symbol, so there's no line underneath it. So that tells me I'm going to have an open circle on 0, and my arrow then is going to be pointing to the right. Likewise, for the bottom one, it says x is less than or equal to -1. So the less than or equal to means I have to have a closed circle. And then I'm going to draw my arrow here to the left. Again, that's because my variable is listed first. Now for example 3, we have a story problem. It says food can be labeled as low sodium only if it meets the requirements established by the federal government. Use the table to write an inequality for this requirement. So for this example here, we are looking at low sodium items. So that means that we're ultimately, when I look at my table here, we have sodium free, very low sodium, or low sodium, which is right here. So if I have to write an inequality for this, and you can use whatever variable you like, I'm going to put L for low sodium. So low sodium food, it says, is at most 140 milligrams per serving. So when it says at most, it means it can be 140, but as soon as it turns into 141, it's no longer considered low sodium. So that means I can include the 140, and because 140 is the most in which it can be, that means that everything else has to be less than or equal to 140 milligrams. So this right here is how we write an inequality for low sodium foods being at most 140 milligrams. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and we'll see you in class.